This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Giovanni Asproni, and today I'll be discussing developer productivity with Hans Dockter. Hans is a software engineer and the creator of the Gradle build tool. He's the founder of Gradle Inc., the company maintaining and developing Gradle, and which is behind also Develocity, a developer productivity platform. Hans, welcome to the show. Is there anything I missed that you would like to add?
No, I think it was a great introduction. Thanks for having me, Giovanni, and looking forward to our conversation today. I'm very excited about it.
Well, me too. The pleasure is mine. I'm very excited as well. I find this a very interesting subject. So let's start. What is developer productivity?
You start with a hard one. Yeah, so for me, developer productivity is a theoretical potential for how productive a developer can be, right? And then there is the actual productivity of a developer, right? And for me, the developer productivity is about how close is the actual productivity to the maximum productivity your development team could provide to you.
So in intuitive terms, what we mean with productivity is kind of number of features developed per unit of time, is something else?
Yes, I mean, there's the whole space framework, right? I think it is multidimensional, right? So for me, every metric that we can quantify is only a reflection, right? Or a hypothesis, right? How this could affect the actual productivity. Right. I think we cannot reduce productivity to a metric. What we can do, though, there are a lot of metrics that indicate that your actual productivity is far from your maximum productivity. So when you know that feedback cycle times are 2 hours, when you know every second build fails with flaky test, right? And you have a lot of unnecessary interruptions. You know there is a huge impediment, right, that reduces your actual productivity. And that is what we are focusing on, right? What are the roadblocks? What is, by definition, right, affecting negatively the productivity? Let's say if a development team works in a perfect environment, right, then kind of from perspective, then the machinery has done its job, right? That's what we are focusing on. But then to measure what is really productivity, I don't think at the moment we have the metrics. Only, let's say, in thought experiments, yes, if someone doesn't commit any code, it's probably over a year, there's probably not much productivity. But otherwise, all those metrics that you talked about could be gained.
When we talk about productivity, developer productivity, now there is this whole field. Maybe, I don't think it's very new, but certainly now seems to be gaining more traction, the developer productivity engineering.
Yes.
Yeah. And what is this about? It's about finding methods to improve this developer productivity.
Yes. So the way I look at it, in theory, it's not new. For all practical purposes, it's new. And why I say it's new, I think when you look 10 or 15 years back, right, the people who worked on productivity, let's say the people who worked on CI or the people who worked on build systems, right, or on the builds, right, were considered not good enough to work on the production code. So that's why I would challenge it a little bit. It's not new. I think as a discipline in software, it was a completely esoteric and niche thing, hardly any organization focused on and appreciated, right? So that has fortunately changed, right? And DPE, right? So there are many dimensions that affect developer productivity, right? Could be the food in the cafeteria, right? Or, many, many things, but that is not what DPE is focusing on all the dimensions, right? DPE focuses on what I think is the biggest impediment to developer productivity, and that is the tool chain, definitely in an enterprise context, right? There's a lot of other important vectors that affect it, but that is at the heart of I would call it a developer productivity crisis that we're in, right? That we're slowly awakening to. That is at the heart of it. And DPE is a practice, right, that tries to professionalize how we look at the developer tool chain and how we improve it.
Okay. And now, why is developer productivity so important?
Because the actual productivity is far, far, far from where it could be. So there is a huge waste, right? If that weren't the case, then we wouldn't need to have that conversation. But the reality is that there is a transformational opportunity for organizations, right, to get order of magnitude improvements when it comes to the output, or at least many factors of improvement, right, of their code output if they invest into this area. And some organizations are showing that this is possible, right? That's why it's so important. That's why I'm intrigued working in this area, because it's transformational in my opinion.
Yeah, okay. Yeah, I agree that there is a lot of waste in software development in many projects. I mean, I've seen many of those cases where we waste time and effort, and and there is a lot that can be done to improve the situation. But now I've got also another question, because when I think productivity, I'm thinking also about developer experience. They were, you mentioned the tool chain. So what is the relationship between, developer productivity and developer experience?
Yes, I think it's at the heart of the developer experience crisis, if you like, is the developer productivity. I mentioned this wonderful book by Ilya Prigogine, one of the great physicists of the last century. He calls it Man's New Dialogue with Nature. The way he looked at it is, right, as a scientist, you formulate a hypothesis, right, and then you enter a dialogue with nature via experiments to get feedback on that hypothesis. As a developer, right, we write code, which is a hypothesis, and then we need to enter a dialogue with the toolchain. Hey, compiler. Hey, unit test. Hey, functional test. Hey, regression test, right? What do you think about this hypothesis, right? Give me feedback, right? Is it doing what it's supposed to do? Is it breaking something? Is it fast enough, right? All of that, right? And that dialogue is at the heart of what we're doing. And now we come to the experience question, right? When I started coding C64, right, back in the days, right, it was like, my print hello world, right, was fast. There was no waiting, right? So I could formulate my hypothesis and I would get instant feedback. And I don't know if I would have gotten into programming if I had the experience of a enterprise developer nowadays. Oh, it takes 20 minutes to get any kind of feedback. Half of the time the feedback is not correct, right? That would have destroyed all the fun why I got hooked up in software development, because it's the flow, right? Hypothesis, feedback. Let's try this. I have this question, right? And that's so much fun when you can move quickly with that. And when you are now bombarded with a slow, unreliable tool chain, it's one of the most frustrating things in the world, and it takes so much fun out of the job. Furthermore, right, you have pressure to deliver. And the space framework people write a lot about that, right? They say when the impediments are so strong, then the only way you can deliver what is expected of you is by doing heroics, basically burning yourself out, right? Doing 4 extra hours to even get the kind of to be expected stuff done. So, and those two things, the flow, right, the instantaneous experience between hypothesis and feedback, plus the pressure to deliver and then having a blunt knife, right, that I think both, there's nothing that affects the experience more than that in a negative way in the life of a software developer in most environments, right?
Okay. Now let's talk about, the key factors affecting productivity. Surely you mentioned already the tool chain. Maybe you mentioned in passing slow builds or long feedback loops, basically the tool chain. But are there other factors that affect productivity for developers? Because I was thinking about, things that sometimes you mention in some of your talks, like cognitive load, or maybe other things like, I don't know. Well, we'll talk maybe a bit more later about this. But for example, things that have not much to do with developers, with the developers as in with the writing the code or creating the system, maybe, unclear requirements, things like this.
Yes. So I would say, sure, the code base is in a really bad state, right? And now you have to work on this, right? Or toxic work environment, which is not probably a complete exception, right? So yeah, 100%. There are many factors. So let's go into the cognitive direction. The brain is I would say, at the leadership level, is not a very well understood production means for code, right? And there are a lot of naive assumptions, right, that I think create negative outcome for the organizations. What do I mean with that, right? So when you look at what neuroscience tells us, right, there are 2 types of cognitive activity, right? One is where you have pre-established neural pathways, right? Completely learned cognitive activities. Like, so for example, professional chess players, when they do the opening of a chess match, right, they don't have to think much, right? You can wake them up at 3 a.m. in the morning and they will do a right opening move, right? Usually. And because this is learned, they don't have to think about it. And other things is like when we are crossing the street, we're looking in the right direction, unless we're in England. And I don't have to think about it. Oh, where do I need to look, right? Those can be very complex cognitive activities, but they're completely learned, right? So, and then we have activities that require cognitive control. And those are the really interesting ones. Cognitive control activities are where we know the goal, where we look at the inputs, but we don't know yet how we get there. Like in the middle game of a chess match, right? There are exponential opportunities. There's nothing pre-learned anymore, right? So you need to look at the inputs and what do I'm trying to achieve, right? And then you need to find a way, right, to get to this goal. And there is a lot of research around that in neuroscience. So what you have to do is you have to dynamically create a model in your prefrontal cortex where you model the inputs, where you model the goals, and then you figure out how to get there, right? And all the valuable coding activity falls in that area. You need cognitive control. There's not a pre-learned thing, right? You have a requirement and now you want to have a certain outcome with software. Now you need to think about how to achieve that, right? So, and activities that require, mental activities that require cognitive control, they lead to cognitive fatigue, right? So, and now what does it mean in the context of developer productivity, right? Ideally, right, I have 100% conversion of cognitive fatigue in code, right? I start in the morning, I have the perfect environment, and all my cognitive fatigue gets basically converted, right, into great code for the organization, right? That would be ideal. And then after 8 hours or whatever, I go home, I'm fatigued, but, I got paid for that fatigue. And the company has hopefully, a lot of good code, right, that creates business value, right? So, and now the way I look at this, a lot of non-productive stuff that is happening that is accelerating cognitive fatigue without getting any business value out of that.
So if I'm understanding your point correctly, of course, there is this cognitive load and cognitive fatigue because, what we do is transforming our thinking into something that runs on a machine, I guess. And you say this kind of the tool chain we use can be a problem. You mentioned flaky tests, but even long feedback loops. So say the build that is too slow or other factors that something not working well will actually affect the feedback loop, and this will actually cause some cognitive fatigue because we are there waiting for something to happen,
yes,
potentially
exactly.
doing something else. Okay. Now, what do you think about the cognitive fatigue also due to the fact that sometimes, maybe we are stretching ourselves a bit too much. So, for example, a lack of the necessary skills or the fact that somebody is using for the first time some tools.
So a good example is, right, so many organizations, I know Microsoft is a proponent of that, right? They're looking, when we hire a new developer, when do we see the first commit, the first pull request, right? And they consider this as a primary measure for how good their onboarding is, right? And that goes to what you're saying, right? How much cognitive energy do I have to burn to start getting productive, right? When I start working on a new project, right?
So Microsoft does that, so to decide how to improve their onboarding process.
Yes, and they have some very interesting data. Brian Hauk, he's presenting on that regularly. He's one of the co-authors of the space paper. He's working for Microsoft Research. They say the interesting thing they found is when the first pull request is earlier, then all the other pull requests that come are also earlier, right? So this is for them now a strong measure that they will get, that this is a sustainable productivity gain, right, is indicated by an early pull request.
Oh, okay. And I think also you mentioned before about also code quality. So I was wondering also if the code quality acts as a potential productivity blocker because, especially developers that work maybe on legacy systems or systems that have been created without any test documentation. But in that case, it's not about the tool chain that much. It's more about what the material you're working with.
I'm biased, right? Yes and no, right? So what we often see is if you have no test, there's a problem. But what we often see with legacy project is that the toolchain experience is terrible. But then the organization saying, this is not the future. We do not invest into the toolchain. And so let's say you have a very hairy, very coupled toolchain. So you have to do complex refactorings, right? Let's say to extract some microservices out of that, right? And now when the build takes a long time, when the test quality is poor, either the reliability of the test or the test coverage, right, then it's so much harder to work with a legacy code base. Yes, even with the best tool chain for a badly designed legacy code base, that affects your productivity. But often it goes together, a bad code base with a really bad tool chain experience. And that makes it so hard then to improve it. So I'm biased. I always have a tool chain perspective, right? That's just that's why I've seen it so often as the primary bottleneck. So I agree with you. There are other things here, but even here, the tool chain, when we look at this in reality, often is a main contributor why it is so hard to work with this legacy code base.
Have you got any examples you can give us? Of course, without naming names.
Yeah. So for me, and that is probably most larger companies in the world, right? It starts with the reliability of the feedback, which I think emotionally is even worse than the waiting time. So you have a pull request built and it fails, right? So, and ask any company, right? And I like to do this as a survey when I present somewhere. How often in the last 4 weeks you had a failed pull request build? You looked at it and you said, I have no idea why this has failed. Let's run it again. And if it passes, good. Then I move on. There is so much. So we see many companies where 5 or 10% even of their CI builds are failing because of flakiness in the pipeline. And all of that creates a disruption. Oh, I have to stop doing what I'm doing. I need now to look why this is failing. But it's not your code that it's failing. But you don't know. You just see it's failed. Is it my code? Or is it something in the CI environment that is not reliable, right? And this is just...
Actually, have you got any information about how often is in the code and how often is the CI environment? I mean, are there any statistics out there about this?
Yes, in this case, so we measure some of that. And that's why I'm saying 5 to 10%, right, of the failures are CI environment related. And that's a big number, right? We're talking about, millions of builds. But that is not even, let's say it's 50-50. The problem is, right, the developer doesn't know that the worst thing, it doesn't know, is it the code or is it the environment? And then what do? Then you say, let's file a ticket for the infrastructure team. The infrastructure team says, it's a failing test. What have we to do? You look at this. No, you have to look at it. It's not me. This is a daily dance in 99% of the enterprises of the world, right? I know organizations that have a whole team on the infrastructure side working on triaging failed CI builds developers file tickets for. We're talking about 10, 20,000 tickets a year, right? It's terrible. And then the developers, they want to merge their pull requests. So they're stuck. They need to wait until the ticket is looked at, right? And the problem is the percentage is high enough, right? If the percentage that developers, that they think it's very likely that it's not my code, right? And then they pass it on. So the number is very high, right? Of pipeline flakiness. And it's creating so many disruptions, so much waste. It's one of the biggest problems that we're seeing out there and hugely frustrating for everyone involved.
Yeah, to me, from what you say, seems that the machinery there can be either of help if it works well. Let's say with the legacy code, if you have build pipelines and build tools and everything, and maybe tooling for refactoring that actually work well can enable you to improve the code base. But if they are flaky or don't work well, they actually worsen the situation, are kind of amplifiers in a sense.
Giovanni, and now an interesting thing is, right? And again, I guarantee you that every company in the world, this is happening every day. Your CI build fails, your pull request build, you run it again, it's green, okay, this can be merged. So there obviously is flakiness, right? You haven't changed the input, now the result is different. Now it works, it's green. But you made a good point. In many cases, they don't know. Do I now ship a flaky product to my customers, or do I just deal with a flaky CI pipeline? We don't know. The customer will discover that, right? And this is happening every day, many, many times.
How does the team structure affect productivity? I mean, not the single team. When you are in a multiple team situation, are there any effects on developer productivity directly measurable?
Yes. So when you're saying multiple teams need to work together on a certain software deliverable.
Yes.
Yes. So that is a very interesting question, right? Because you could argue, isn't that then one team?
Well,
you know what I mean?
Yeah.
Right. So are you talking about time zones? Right. Because for me, if they're all working together, we should look at them as one team.
What I'm thinking of, let's say a team like people that work on the same service. Yeah. A team of say 8-10 people. Yeah. Usually these teams are around in between 5 and 10. One team. But then we have the situation of teams. So you have 2 or 3 or 4 or 5 or 10 or hundreds. I've worked in projects with really hundreds. And so each of these teams of 10 people work on a subset of the bigger system. Yeah, but all these teams together pretty much create the entire system. And so I was wondering if this kind of the structure of this setup can actually affect productivity as well. And tell you where I'm coming
Yes.
from, because I've seen situations of teams waiting for other teams to be done with their work. This is one example.
Oh, so it's a very interesting topic, right? And it leads us again to the tool chain to a degree, right? Because how is this work organized? So for example, do you work all in one repository, or do you have now many repositories that integrate somehow? And for example, one problem we're seeing, right? So with the whole microservices movement, I think things went over the top and people started to create many repositories, right? Which is a pretty heavyweight abstraction, right? With very small amounts of code. And now you have to sync the work between all those repositories, right? And you have a very complex dependency graph because now all the output is versioned independently, right? That complexity has created a lot of problems, right? Another thing is in that situation you have described, right? When you have many repositories. So let's say you are producing a library that is consumed by a lot of other teams, right? In the organization or service, doesn't matter, right? So what is really a problem is, so now you change something. How do you make sure that you haven't broken the consumers? You don't even know your consumers in that world, right? You know the stuff you are consuming. You have no idea who is consuming you. So now you change something and now the consumers have to run into problems, right? And let you know. Because the test you're running, because you don't know your consumers, you're only testing your stuff, right? That test your functionality, but not how your change is affecting the consumers, right? If everything were in one repository, right, that would automatically happen. You would run all the tests of all the consumers, all the producers, right? And then they're green and everything works. So the microservices world has really created problems, right, in that respect, as I've just described, and it makes collaboration more difficult.
Maybe those problems, I think, are solvable problems, because with microservices, if you really want to use them, is you can always have versioning of the interface, the API, yeah? So it's like you have version 1, you create version 1.1 or version 2, depending. And so you can, of course, serve the old consumers and the new ones. But this creates additional work probably because you need to manage versioning of the APIs and potentially additional tests because you have to keep testing different versions of the same API and then come up with deprecation mechanisms and all sorts of stuff.
I agree with you. It's solvable. I'm just saying it has created complexity, right? For having teams working, in multiple repositories that has created productivity issues. So yes, I'm not saying it's not solvable, right? But it has definitely created integration problems that makes that work less efficient, right? Otherwise, I think another area, right, is that people have when different teams have different development philosophy, right? So that is now I'm going the reverse, right? Let's say you work in one repository, right? And with people that have very different perspectives on testing, right? So for example, you have now team members that say, I don't care about flaky tests, right? And basically you're now running a build and they're now always test failing, right? That are not your tests, but you cannot get it to the pipeline, right? If those tests are failing. And you now have members maybe in a different team that work on the same repository that just say, oh, just ignore it, just merge it anyhow, for example, right? That is another thing where we see a lot of frustration that there is just not a joint development philosophy. And because it's different teams with different leadership, you can also not escalate easily, right, with them to fix that. So that is definitely something that can be very frustrating.
In that situation, I guess that the machinery has some limitations of what it can do because there is an element of actually people agreeing on something.
Absolutely. This is where the toolchain can only say, I wouldn't say the toolchain, this is where no, I fully agree with you, but what we need here, at least as a potential way to, I wouldn't say to solve it, but to kind of pinpoint the problem is, let's say you're now in a situation where you're going to your VP and saying, man, those flaky tests, right, that are introduced by a subset of the group is killing us, right? And then the answer would be, well, how often is that a problem? And then what do you think? How many people would tell you, hey, we had so and so many flaky tests over the last 30 days? No one. And then it becomes a gut feel. And the other team is saying, oh, they're exaggerating. It's not that much of a problem, right? So the lack of observability. So I would say if you have you can derive very interesting data from the toolchain that can point to organizational problems, and it allows you to quantify them versus making it a a finger pointing exercise that is arguing from the guts.
I can tell you that in a very large scale project that I consulted for years ago, they had such a problem with the flaky tests that they decided that if more than 90% of the tests were passing, they declared the product good for release. But there was an additional problem, that was this 90% was not always the same test because the flakiness, was the total percentage, but the test failing could be different tests each time. So it was really a gamble.
Yes. And I think, and the other aspect of that is then it really demotivates people to write tests.
Yes. Yeah,
Right?
I agree. But I agree. The good machinery, good observability can help in figuring out, or at least in highlighting the organizational problems.
Yes. And then, of course, if you have a dysfunctional organization, nothing will happen in any case, but then it's time maybe to leave.
True.
When you have a chance.
I can ask you also, in your experience, what are some key metrics or indicators that teams can use to measure productivity effectively?
Yeah, I think for me, so going back, right, to the dialogue with the toolchain, right, I think how many dialogues the developers do is almost like a survey every day, how much you like your toolchain and how high the tax you mentally think you're paying for getting feedback. So, and this is fascinating, right? I mean, we all know this horror stories, right? We know one organization, still big enterprise software company, their turnaround time for a full feedback cycle is 24 hours. 24 hours, right? And everyone understands that's a disaster, right? Or 3 hours or 2 hours, right? So that is where everyone emotionally understands that's terrible to wait so long for feedback. Okay.
When you mention feedback here, you mean a feedback on, say, a pull request, feedback on...
Okay. Feedback on a pull request. Good question. Yes. Because they're very different level of feedback. Thanks for asking that. So, okay, now we did some research, right, with projects that are in a much healthier state, right? So one example was where the organization, one team was having a 1-minute build, the other team, similar tool chain, a 4-minute build. And the team and both sounds like, what's your problem, right? That's great. 4 minutes. Hey, who's complaining about that? And they weren't complaining about it. But what we could see is that the team with the 1-minute build time had twice as many builds and test cycles than the team with the 4-minute build time. So the 4-minute build time was already a tax they were less willing to pay, right, than the team with the 1-minute build time. And that's, I think, where we as an industry, right, need to develop. Yes, we have all those nightmares, hours, and everything is terrible. But even if things is in a pretty good state, at least from a current perspective, right, improvement still makes a lot of sense. So that is another thing that Microsoft has basically done some serious research on, where they're saying we can now correlate basically every second of improved feedback cycle time goes into more code, right? Anyhow, so I think this kind of how often do you ask for feedback is for me a very important metric. And the differences we see between organizations and teams are astonishing. 2 orders of magnitude, right? Sometimes, right? How often you ask for feedback. Right. And that is one metric that I think is a key metric.
Basically, so here we are talking about, the feedback loop for pull requests, how long it takes, then the build time as well.
Yes, also local builds, right? How often you run local builds?
Yeah.
Your pre-commit build before you even submit the pull request, right?
Okay. And is there also frequency of commits? Is it a good metric or?
It's a very good metric, right? Because there is a really toxic correlation. The longer your build time, the bigger is the change set of your pull request. Because, hey, I don't want to pay this tax. It's just 50 flaky tests I have to deal with. It takes ages. Then I have to deal with all this stuff. This is a flat tax, right? So let me get a bigger change set going to make it worthwhile, right? And the problem is with all of that, even with the long build time, right? The happy path is not so much a problem. If your builds are always succeeding, right? You have large change sets, you have a long build time, it's not so much of a problem. It's fire and forget, right? They're always succeeding, right? Everything is good. But unfortunately, they don't. Now you have flakiness combined with a very large change set, right? I mean, the debugging nightmare that is causing, right? Because there's so many dimensions that are now responsible, right? So it's a huge problem. Yes. So I think number of commits, a lot of commits, small change sets walking to the pipeline is for me one of the most important health metrics.
Okay. Can I ask you, some maybe, let's say, off the cuff numbers that you think are good numbers? Like, what is your experience? What have you seen in the best companies, for example, that use pull requests? How long is the feedback loop? We are talking minutes, hours, days.
I would say we see many organizations where when you take everything into account, the flakiness, how often you have to run it, the tickets you file until they're fixed because your CI built green again, right? It is often hours, right? And for the best companies, it depends, of course, right? But this is in the area of minutes. So that's where I'm saying there's really two orders of magnitude, right? Within the, I would say, ignoring the extremely pathological cases, right? Where this is even worse.
Yeah, well, I've seen pathological cases of really 1 or 2 months for a pull request. Of course,
Yes.
then when you merge that, is a hell to merge anything because of
Hell,
all the changes.
that's because, so you're making a very good point, right? Because the big change sets, now the likelihood of major merge conflicts, right? And that is for me the worst thing in the world. Merge conflicts are just, oh my God, right?
Actually, now that you're talking about pull requests and merges, and have you got any, maybe with your tools, metrics, or have you seen any metrics with your customers around maybe comparing teams that do, if you have found any, that do pair programming and trunk-based development compared to teams that maybe do more pull requests and more solo working? Have you come across any interesting numbers?
No, unfortunately, we haven't started to instrument that. So that would be super interesting, right? To look at that with different types of development philosophies, right? Or approaches. That would be super interesting, right? So one thing, the story I wanted to share is there was this company, and it's a while ago, right? But they had a big monorepo and their build time was 6 to 7 hours, right? If it passed. And leadership was saying, we need to do Scrum. We need to have weekly sprints. Right. And I said, okay, let's do this. Right. And the problem was they were not even able usually. If they were lucky, they got one working build a week. And that's your point. It took them months. Right. So, and sometimes, and the only way often they got a working build for a week, they had to tell everyone, freeze, no commits anymore. And then how do you do Scrum? Right. And then the testing team had nothing to do initially. Right. And then when they were getting close to their release date, it was like all hell broke loose. It's exactly what you're saying. So the whole idea, hey, we want to introduce Scrum, when you have that kind of feedback cycles, right? And before you get a pull request through, forget about it, right?
Yeah, well, you have to make some deeper changes to everything pretty much.
Yes, exactly.
Okay, so just now, before move on, I'm interested. So in terms of interesting metrics, we said the frequency of commits is an interesting one. That length of the feedback loop for pull requests seems to be another good one. Are there any other that you suggest as in, generally good ones to look at?
For me, super, super important is how early do people ask for feedback? Right? Because we want to shift left, right? We want that developers work in small increment and ask as
so
early for feedback. So
when we say how early they ask for feedback, what do you mean exactly with the asking for feedback?
I will explain. So for me, a very good metric is number of pull request build versus number of local builds, right? So if we see that developers stop running local builds, often because the experience is to do this, right? Then they say, it's such a pain, right? Let's do this on CI, which means they will do it much less often and later. Then you're shifting the whole thing to the right? Or because maybe the machine, when they run their tests, have to run it on their machine, and then it consumes so much load from the machine that they cannot work in the IDE, right? That is something. So you want to shift them left. And everyone says, every organization, shifting left is great. We have to do this. This is our philosophy. And the reality is, though, it's shifting right at this point in time. Right? Because the code bases are growing, right? So I think it's super important that people take care of the local feedback experience. And it's often completely ignored because you have zero data about it.
Yeah, that is quite interesting, actually. It's quite interesting. And I think, to add a bit to this point, I've seen situations where, in theory, the company management wanted to do the right thing, okay? In practice, they gave developers underpowered machines that were not able to do much. So maybe not enough disk, not enough memory, not enough processor power. And so I've seen situations where for the developers, pretty much a local build was not really an appealing option.
Yes. I can tell you a funny story, right? And so before I tell what I think is a funny story, but then you need to think about. So I really think that the MacBooks, the MX processor, are a game changer for development, right? And they really expanded what is possible to do on a local machine significantly, right? So that is very exciting, right? But there are still limits, obviously. So that is where I think technologies need to come in. Like, hey, you run your build locally, but you can run your test, right? You just run your Maven, your Gradle, your SBT, whatever build, right? But the tests we take and run them on distributed agents, right? To take that load away from you. Or Facebook has pioneered that, right? There is technology like predictive test selection where we use an AI model, right? Or where you use an AI model that predicts, hey, for this change, let's say 900 out of your 1,000 tests with 99% likelihood will succeed. They're not sensitive to that change. So let's weaken the quality gate a little bit, right? But with the advantage that you get much faster feedback with much less resources. So there's really interesting stuff. And that's where DPE comes in, right? To think about this, to model this, to create this kind of back end, right? So that you can actually get early feedback. And the funny story I wanted to share, there's a company that their build time was going 15 minutes, 20 minutes, 25 minutes. And the developers were supposed to always run local builds before they commit and push something. At one point, they were escalating to the VP. We cannot do this anymore. It takes way too much time, right? And you will like that story. So then they established a task force, right? And task force was trying to fix it. And the goal was to get it under 5 minutes. And they got it down, I don't know, from 28 to 22 minutes with some improvements. It was far away from the 5 minutes. And then they came up with the solution. And they were quite convinced that this was a good solution. They said, hey, just stop running the test locally. And boom, everything was under 5 minutes. And they were pretty proud about it. And I was like, okay, whatever, right? Great.
Yeah. It doesn't seem to be a good solution.
No, it doesn't, right.
Okay, and now let's talk about steps to improve productivity in a company. So, say an organization, they have problems. Maybe they are not measuring much at the moment, but they have the feeling that everything is slow. They want to go faster. This is a typical thing in most organizations. Everybody wants to go faster. So, what are the first steps you would suggest?
It's very easy. And now we're coming back to the management. So the thing that was eye-opening for me years back was so Android is mobile in general is a more complex platform than doing, let's say, microservices with Java for the backend, right? So because there is so much stuff that needs to be done for building mobile applications, build time is particularly a problem, right? And then the Google Android team developed then a lot of improvements, right, for making this faster. But then quite a few of those improvements required that you needed to reconfigure and redo your build and some things in your code, right, to get benefits from this. And they did it because all the surveys the developers saying that's our biggest problem by far. Now they've offered a significant improvement, and now less developers than they thought were making use of those, right? And then they did a big survey, right? Why is this the case? And the developer said, our biggest problem is to make the business case to the management that we get resources to do this.
I see.
So, and let me give you a concrete example, right? How it works in most organizations. So many organizations move to ephemeral CI, right? Let's always throw the CI environment away before you run the next build. So all your local state, your local caches are thrown away. And it's culturally, maybe we have time to go into this, right? But why this happened and not what. But the CI build time has drastically increased because of that, including pull request build. And a big part of that is now downloading all the dependencies over and over again. So you have no idea how many people came to me and said, oh, dependency download time is a big problem. And then I was asking the most naive question in the world. Well, what is your average dependency download time? We don't know. Across the board. There's not a single organization almost on a planet that could tell you what is the actual dependency download time, although everyone is complaining about. So if someone would come to me in my company and would say, man, dependency download time is a huge problem. We need 5 people to fix it. I would say, well, how big of a problem is it? Right? And then, we don't know. Everyone is complaining about it. And that puts you in a paralysis state. So am I now willing to invest into this when I cannot quantify it? So then it's, maybe let's put half a person on the problem. Right? But the reality is now when we measure this at some of those organizations, we see easily 30% of the DCI build time is just downloading dependencies. And now you can have a conversation with the leadership saying, look, this is 30% that cost us compute resources because the CI machines are idle while downloading dependencies, right? It cost us 1 million minutes per whatever period of time, right? Now you can have a conversation. Now you can make a business case. So the answer for me is therefore observability is everything. Don't even start on anything gut feel wise. You need to measure. to see how big the problem is and the particular problem, and then to measure what is the improvement, right? So people always thinking, oh, there are some silver bullets, right? So let's introduce a new technology without any observability. So for me, it all starts with observability, with instrumenting. And that's how we would do performance improvement of an application, right? Yeah. But that is the kind of immaturity we still have in that area of the software industry, right? That we're not applying best practices we would apply in other areas.
Am I correct if I interpret this as we developers, technical people should actually do our homework first, get the numbers, and then when we complain, go there with appropriate information so we can have a conversation?
100%. Otherwise, it's just developers whining again. All those developers, right? They're never happy. There's another, it's one of my favorite stories, right? Because it shows the cultural kind of mismatch. So we were talking with a big car maker. They wanted to talk about developer productivity. And it's a little bit mean. I always ask those questions, right? Very simple. How many feedback cycles do your developers run per day? What is the average time of them? And how often do they fail? The most innocent, simple questions you can imagine. And the answer I was getting is, we don't know. In this case, the answer was, well, we need to do a survey to figure this out, right? And then I said, well, if I would go to any of your factories and would ask, how long is assembly part A, right, taking to get from there to there? How long is it sitting in a shelf? And I would get an answer on that in 5 minutes. The person would be fired. It would be culturally a disgrace. People would be ashamed. It's beyond just, rational. It would be like, this is not who we are, right? And that's where we need to get as a software industry for our own stuff. You put it perfectly, right? We have to do our homework, when it comes to that.
Also, one other thing I was thinking, at least, you can tell me this, if it matches your experience. In my experience, and apparently also in literature, there is a lot of work that developers do. So let's say that they have the perfect machinery, that everything works fine. But then, if you look at the literature, and at least also in my experience, and probably you've seen this with some of your customers, is even for the features we produce, usually there is a kind of Pareto rule thing that is pretty much 20% of the features we produce are the ones that are used. The remaining 80%, we could have avoided them. So I was wondering, from a management perspective, maybe looking at that first, which is probably a bit more difficult than measuring developer productivity with the machinery. Looking at that could be another attack point, because that would free up some productivity for developers to do something more useful.
Yes, so I absolutely agree. And the question is, I think the likelihood of this to happen, that you do not the most important stuff, increases with cognitive fatigue, right? If you're fatigued, you rather do incremental stuff, right? Something you feel familiar with, than thinking about what is actually the most important thing, right? So, there could be many reasons for that, but fatigue can be one major reason. I see it even in our company, right? When you're fatigued, you don't see the forest for the trees. It's hard to kind of think about the bigger picture, because that requires a lot of cognitive control, right? So if you are in a fatigued organization, I think it's very unlikely that they work on the most important stuff.
So if I understand correctly, you're saying that fatigue acts as a kind of an amplifier for this problem again, because
exactly.
It's like brings you to look at the familiar, or in general, it spend less time thinking about what is important and what is good.
So one thing I found fascinating is, how do they measure cognitive fatigue in the cognitive science experiments, right? And because they're still not 100% sure of the biological root cause of fatigue, right? They only know it exists, right? So how they measure it is in many of those experiments, right? So let's say they let you do a lot of context switching, right? To kind of accelerate fatigue, right? Some math problem here, then a word problem here. You get the idea, right? And then they always give you two choices, right? One is low cognitive effort, low reward. The other is high cognitive effort, high reward. So let's say $10 if you solve the difficult problem, $1 if you solve the easy problem. And when people start switching from difficult to easy, that's the indication they're now fatigued. And that kind of correlates well to what you just described, right, in software.
Okay. Yeah, I never thought about this from this angle. That is quite interesting. Now, another question. So we talk about management and developers and how our homework to put things to managers. Now, let's say that in a company, people decide, okay, we'll do some developer productivity engineering, and then we put the tools in place to measure everything and to have the metrics that are of interest to us to improve the situation. Yeah? Who owns this metric? Who owns the developer productivity as a concept in an organization? Developers, managers, both?
Yes, it has to be both. So what we see, and that is a very promising thing, right? Even in the, let's say, non-tech industry, let's say financial world, right? We now see developer experience and developer productivity metrics have C-level ownership. I think that's extremely important. Otherwise, you're not getting anywhere, right? If that is not at the highest level considered strategic, it will always be deprioritized. Right. So I think that is super important. And that leads us to an interesting topic. So we talked about metrics, right? That, let's say, are now owned even at C level, right? That indicate improvements to developer productivity. I think what has happened in the last couple of years, that metrics were perceived as measurements how good the developers are. So basically, there is now a C-level team that now starts instrumenting developer productivity to find out who are the bad developers, like naively said, or the non-productive ones, right? And use that then also to make personal decisions, right? And I think, not even talking about the ethical aspect here, I'm just talking about the economic aspect here. This is absolutely wrong, right? Because when that starts happening, those valuable metrics, let's say number of builds, people will start gaming it. At the moment, people are honest with how many builds they're running. It's a survey about how good is the toolchain experience. When they learn about, oh, this is now how we're getting measured, right? People will start gaming it and completely destroy the value of that metric. So that's why I think there need to be some form of contract. Yes, those metrics are very important to us, but we understand that we cannot draw naive conclusions, to the quality of the teams or the developers based on those metrics. But those metrics are important, and the developers need to be part of the metric discussion to understand what is the root cause that this metric is bad. How can we improve it? So the metric should be a guideline to improve the machinery and the environment versus looked at it, hey, this is now a tool to measure how good you are, right? I think that's super important in my opinion.
Can I ask you a question on that? So we already said that your company created a developer productivity platform, this Develocity. But this question is about now this aspect that you just mentioned. Is there a way to put in these platforms provisions so that it's difficult to trace back to individuals what the metrics, trace back the metrics to individuals?
Yeah, so some companies, especially in Europe, right, they even have legal requirements to do so, and we can hide all the personal information, for example. But I think it's a pity that we have to do that, and there's something culturally wrong when we have to do this to protect developers, because we lose very interesting information, right? I want a developer to see for themselves, right? Oh my God, right? Why is everyone else in my team? Why am I the one with the build time that is 5 times slower than everyone else? Oh, I'm the only guy in Singapore, right? And there is the caches are so far away from me, right? So there is so much value in being able to break down the metrics. If they are looked at it from a collaborative perspective, hey, we want to improve the environment, right? You lose information, but yes, there are ways to do that, but you pay a price for that. And it's sad, right, that you have to do it to protect developers. Something is wrong with the culture, in my opinion, if that is necessary, right? But it is possible, yes.
Yeah, I have to say that I've seen in the past, I consulted for a big company on a big project, and there was a major cultural problem there in terms of trust. And the CTO, they are mandated that developers had to do a certain number of commits per month or else. Yeah, engineering managers had to do at least one per month as well, because he wanted an organization of technical people. But it's interesting. What happened there was exactly what you mentioned before. So some people that were not really doing much development every day because they were doing other useful work, they changed inconsequential files, text files, something that could appear in a commit, because they knew that people would only look at the number of commits, not what was changed, not the quality of the work or the particular effect. So that was quite dysfunctional.
I mean, with all respect to the leadership there, but I think the person, in my opinion, that need to get fired is not any one of the developers, right? Because this is so obviously stupid and ineffective and setting the wrong incentives, right? Or people, measuring how much you move your mouse cursor, right? There are I know quite a few organizations. And with the remote from home situation, right? You heard about it, right? The productivity paranoia in the leadership. Are people still doing work, or they're just hanging out on a patio, right? Looking at the sunset.
Okay. And then can I ask you, let's say that now we are in a situation where the culture is fine and the teams and the company wants to improve their productivity. They are employing some tools. So are there any pitfalls that the teams encounter when trying to improve productivity?
There was an organization that had a very successful organization, but they had, for legacy reasons, they had a situation where they had tens and tens of millions of YAML files, right? So it sounds very kind of, okay, what is interesting here? But tens and tens of millions of YAML files that they were assembling, right, in their archive files, right, for deployment, right? And that made their build time very long, right? We're talking about just copying those the way they did it, right, and working with them was taking 15 to 20 minutes, right, for every build, right? So, and they were on build system A. I don't even mention any name, right? Doesn't matter, right? And then we did something, right? We wrote them some logic to get this time down to seconds with build system A. Dramatic, right? Improvement. I mean, obviously, right? But then they said, oh, but we want to migrate to build system B. And if we now make build system A much better, then we might lose the mandate to move to build system B. And we see this all the time. They're holding something hostage. So they don't want to do the low-hanging fruit because then people might say, oh, this is good enough, right? Don't do anything more long-term. So they were not applying this change. And the migration is taking years, right? While people still have to use build system A. And Giovanni, I guarantee you, I see this over and over and over again. People, because of the immaturity, right, they use a big problem to say, oh, you can only solve this by doing something strategically. And then they get demanded to do something strategically, although they could fix it 2 orders of magnitude faster, but they don't want to because then they cannot do something more strategically. That is one pitfall that I see.
That seems to be a problem with the developers themselves. The technical people seems to be, they are more interested in doing something new than improving something that is already there, working and delivering value.
Exactly. A new toy, a new silver bullet, right? Absolutely. And that is one part. And I agree, that is probably more than 50% of the story. And then the other part is that it might be the only way to get resources, let's say, for doing something which they think is actually important. So it's a mix of both, but you make a very good point.
Yeah, I think we are getting towards the end of the interview now. So I will ask you to the future. How do you see the future of developer productivity engineering evolving?
Yes. So when you look at, let's say, chemical process engineering, you can study this at every university. There are probably 100,000 PhD theses about every aspect, right, of chemical process engineering. So there's a deep cognitive roots. Tremendous body of research, of empirical research, of theoretical research, right? And it's in the DNA of the companies to apply that, right? That's what I would be looking for developer productivity engineering, that this becomes really also an academic discipline. I mean, it's $1 trillion industry, right? And we're treating the production like it is, we're building a lemonade stand, right? I mean, seriously, right? It's changing now, right? That's, I think, the foundation, the academic foundation and the depth of thinking and modeling, because especially you talked about it, ROI models, right? How do you measure things, right? I mean, we're just at the beginning, right? And academia is not involved yet. Bridging the divide from all the interesting research in cognitive science to what does it mean for software development. Such a body of research there we're not applying yet, right? So those are, building this foundation, and then all the rest will follow, right?
Okay, and are there any interesting developments at the moment, in your opinion, like some technological advances or improved methods that we'll see in the short term? Because what you just mentioned for the future seems to be more kind of long-term vision. But is there something coming in the shorter term, in your view, that we don't have yet?
Well, of course, we cannot finish this podcast, right? Talk about generative AI, right? So, I think generative AI is there, right? And that, I think it increases the pressure. So here's how I look at this, right? So let's say you get the windfall from generative AI and every developer writes twice as much code. Well, the code needs to be built, needs to be tested, yada, yada, yada. So the tool chain pressure, if the experience is right now, good luck when everyone writes twice as much code, right? And then you will not get that windfall from generative AI in terms of getting features to the customer faster, et cetera, et cetera. The other thing, I think it should push us in the following direction. So imagine, we talked about cognitive fatigue, right? So let's say there's an organization where in average the cognitive fatigue sets in 3 hours at 11 a.m., right? in the morning, right? So those people are not going home. There is still busy work to do, rename this, refactor this, write some simple algorithms, right? So which adds some value, although not the 80% value we're talking about before, but it adds the 20% value. So now imagine a world that we're probably getting close to where all this busy work is done by AI. And what are those people doing starting from 11 a.m., right? So I think the companies that push the cognitive fatigue out, right, to later, right, generative AI will increase the competitive advantage they're getting from that. So that's something companies should think about. And then what generative AI can do for the tool chain, right, to make it easier to improve the tool chain, right? One reason is, let's say, for example, if everyone had a perfectly modularized code structure, it would have a huge benefit on build times, on how you can parallelize and cache and reuse, right? Dramatic, right? But hardly anyone is tackling that because modularization is just a hairy issue with the cyclic dependencies and things like that, right? So if AI could tackle some of those hard problems, right, to reorganize your tool chain and the software in a way that it's a much lower cost, that would be amazing, right, for the productivity of software developers.
Okay, thank you very much. I think we've come to the end. I think we've done a good job introducing developer productivity. Thanks, Hans. Is there anything else that you would like to mention, something that we missed that you think would be important to mention?
No, you asked all the questions that covered all the stuff I wanted to share. So yeah, thanks a lot. This was a great experience from my side. I really enjoyed the conversation.
Okay, thank you, Hans, for coming to the show then. It's been a real pleasure for me. And this is Giovanni Asproni for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.